Hello, this is Laura Kimmick, and I am going to talk about math for real life. And the book I'm using is Math for Real Life for Dummies by Barry Schoenborn. That's Schoenborn. And it's available on Amazon as an actual paperback or an ebook. So I believe in math for real life. Because I'm not a calculus type of person. And also when I'm learning this myself, and I like teaching others because that way I teach myself as well. And I can also learn from others. And given you in the having the confidence to relay what I learn and what I know, you know, helps me know even more. So we're gonna start with the math fundamentals, and the basic operations of math actually are just fractions and percentages. That's the basic of mathematics, especially real life mathematics. And there's addition, subtraction, multiplication, and division. And this is good for managing algebra equations and also geometry. And also we got, of course, there's also the reviewing of counting and fundamentals of the four basic math operations. And then, of course, we're going to have fractions, percentages, charts, and graphs and word problems. But not all of this video, but down the road. And numbers is the most important part of math. And believe it or not, over 20,000 years ago, the Ishango bone, B-O-N-E, was used as a tally stick, a counting stick. And then we have whole numbers and fractions, and those are two most important kinds of numbers. So right now, we're going to go over the number line. Okay, so let's make a really short number line. So you get the idea. And each arrow stands for, infinity, going on forever. So 0 in the middle, and then 1, 2, 3. And then we have -1, -2, and -3. Okay, so we have a number line, and zeros in the middle. It's neither positive or negative. And think of 0 as taking nothing whatsoever and putting a circle around it. And it means lack of a quantity. So right there, and on the left here is the negative numbers. Since I'm facing you, left and right will be opposite. Here to the right are the positive numbers. And of course, it's also known as negative integers. Negative. And integers are whole numbers, whether they're positive or negative. And then we have, so positive numbers are also known as natural numbers. And of course, you can put a plus and put a front of positive, but we don't have to because the positive is implied. You just know it's there without putting it there. So they're also known as positive integers or numbers. And numbers are also known as, I'll put over here, integers. All right, there we go. And these are known as counting numbers. Let me undo that, make it closer. Okay, we got the counting numbers right there. And there's no fraction part of integers. Okay, and 0 is like a non-negative number. That's what it's called. It confuses many mathematicians and it causes arguments among them. Okay, so like I said, it's non-negative integer. An integer is a number. Well, you could, another way to put it is 0 is neither negative nor positive. Okay, so that's a non-negative integer. Okay, we got that. And if the number line stretches from left forever and goes on right forever as well. So it's infinite. And decimals and regular fractions, they're part of whole numbers, you know, and they fit somewhere in the number line between the integers. So between here, around in between any of these lines would be like, what there would be fractions or mixed fractions or decimals. And the core operators, for doing math or addition, and I put and right here, subtraction. And then remember multiplication and division, one step down from addition and subtraction. All right, we're going to clear this off. We're going to talk about addition. Okay, addition, and that's a math operation, and it combines two or more, quantities, like two more numbers, to get a larger, usually a larger quantity. So it's the first thing we learn in math is addition. And the operands, there we go, much better, operands. Are, let's see, are numbers. Okay, they can be added in any order. So, and then they have commutativity. I'll write that down. It's a long word. Commutativity. So commutativity. Okay, that means you perform the operation, addition problem, any order. Here's an example of commutativity, rather than like the commutative property. Here's a great example, like 21 plus 34 plus 41 plus 51 equals 144. Then you can do it backwards. 51 plus 41. Oh, let me fix this number. On the erase. Okay, get my, oh. I trying to get my pen back here. All right, so still working. It's supposed to be number 31 right there. Excuse me. All right, here we go. I'm going to erase right now. Yeah, so I'm sorry about that. It's stuck. The eraser. All right. And there we go. Erase. Okay. I'll stop the share for a minute. All right, and we're gonna go back and share the screen again. Get the whiteboard back. All right, got my pen back. So it's be 31 right here. Let's undo that. And we're gonna 31. 41, 31 plus 21 also equals 144. So in any direction, if we, no matter how we put these four numbers, any order, it doesn't have to be ascending or descending. The answer will still be 144. Okay, now we'll move on to subtraction. I'll try not to use that eraser. It doesn't seem to go away. And here's subtraction, another math operation. And you will notice that every operation, addition, subtraction, multiplication, division, have a math operation in common. You take away the value of one number from another, resulting usually in a smaller quantity, as an amount. And the order of operands numbers are important because we rearrange the numbers. When we rearrange the numbers, answers come out different, opposite of addition. Here's an example. 72 minus 22 equals 55. Okay, and then if you do 22, for example, 22 minus 72 is 55. That's right. So it's like 52, 55, 65, 75. Okay, let me check my answer here, make sure I'm correct. Please let me know if I make any mistakes so I can correct them in future videos. Yes, so 72, 2 minus 2 is 72 minus 22 is not 55. So I caught myself there. So I'll use the eraser. If I can't erase, I'll stop sharing the screen for a minute. Let's get that. See if we get the pen back. It never comes back. I don't know why. Okay, oh, so undo, but we don't get the, let's see. All right. Okay, let me do this again. There, my screen's back. And so is my, pen. Okay, so, all right, 55. Okay, 6 plus 10 is 65. Okay, let's see. Let's see if 27 works. Okay, so 7 minus 12. Okay, well, let's start again. I'm going to clear all drawings. Okay, here's subtraction. As you can see, I'm not afraid to make mistakes in front of everybody. And that's how I learned to. Okay, so let's see, 72 minus 22. Let's see what it equals. So 2 minus 2 is 0. Okay, so it's 50. Now, if we do, for example, now we switch, let's switch. Now, if we do it in a different order, like minus 22 minus 72 equals, and be another negative numbers, but a different answer. For example, 72 minus 22 would be, let's see, 72. It'd be very, very different. Okay, let's see what we're doing. 72, 82, 92. So it'll be like negative 94. So completely different. Or I could do minus 72 minus 22. And that would be equal, let's see, still negative 94, because it'd be like adding. Okay, so basically subtraction is different, like this and this are different. Okay, so I'm going to, oops, there we go, okay, we'll keep this, we're done with subtraction now. Well, we go subtraction over one more time. Subtraction, right here. All right. Because and this, the best way to do subtraction is vertically instead of horizontally, like we did before. Okay, let's try again. Like 72 minus 22 is 50, which is a positive number. And now if we do, let's see, negative 22. And then we, plus 72. Okay, then we have, since 72 is a positive number, it's larger, it'll come out as another positive number. All right. Okay, so 72 minus 22 will be 2 minus 2 is 0. It'll still be 50. But it'll come out different if we do it another way. All right. So we can do negative 22 minus negative 72. It'd be negative 94. So subtraction is not very consistent. And then one more review before we move on, since subtraction is more complicated than addition. Start with the lower number, makes it a lot easier. For example, 1 plus 2 is 3. Oh, sorry. Let me undo that. Now with subtraction. 3, this is better, minus 2 equals 1. Okay, so we can go backwards. So it would be 1 minus 2 would be negative 1. So see the answers are different. Positive 1, negative 1. So this is the example. You should follow this one right here. Okay. Now we're on multiplication. Multiplication is just repeated addition. So for example, we can do 3 plus 3 plus 3 plus 3. And plus 3, which equals 12. Okay, so which is just 3 4 times. So you take 3 and you multiply it 4 times, you end up with 12. Okay, it also works for large numbers as well. Like 123 times 7 is, and let's do it again. Okay, so 123. Do it vertically. That's easier, at least for me, when it's vertical, so I don't mess up like I do when it's horizontal. Is so 3 times 7 is 21, carry 2. 2 times 7, 14, 2 is 16. Okay. 123 times 7 right here. You know, it's a carry to 2. Yeah. Okay, 7 times 2 is 14, plus 2 is 16. 1 times 7 is 7. That's 1. Okay, 123 times 7. Okay, 3 times 7 is 21. Okay. And put the 1 down and carry the 2. 2 times 7 is 14. And plus 2 is 16. Put the 6, carry the 1. 1 times 7 is 7. Plus 1 is 8. It's looks like 861. Let's see if I'm correct. I put it 7 times. Okay, 3 7 times. That's 1, carry 2. 2 times 7 times. So 2 times 8 is 16. Carry 1, 7 times. So yep, 861. So it's 23 7 times. All right. So small numbers can work with multiplication and tables. So we can do up to 10 times 10 in multiplication tables. So it makes multiplication, multiplication tables make multiplication a lot easier. So we won't go over the multiplication table. You can look that up on your own. And you can use calculators for large numbers. A calculator is something I don't have on hand right now. And you can multiply the numbers in any order. So 7 times, 123, you can put it vertical or horizontal, equals 861. Okay, so we're going to move on to division. And division is multiples, is subtracting multiple times. So it's like 12 divided by 3 equals 4. Or I can do it the long division way, which is put 4 into 12. Those 3 times. So 12 divided by 4 equals 3. Okay, so subtract 4 times from the number 12. So just do 12 minus 3, the first 3, that's 9. Minus 3 is 6. Yeah, so 12 minus 3 is 9. 9 minus 3 is 6. 6 minus 3 is 3. And 3 minus 3 equals 0. So the operand number order is important to get the same answer. So let me break it down. 12 minus 3 equals 9. Here's the first 3. Now let me undo those. I'll just underline it. 9 minus 3, the second 3, equals 6. 6 minus the third 3 equals 3. 3 minus the fourth and final 3 equals 0. And now we'll move on to fractions. Okay, fractions, there's common fractions and decimal fractions. And these are the most important fractions of all. Common and decimal. Okay, and then fraction, the numerator is the top number. And denominator equals the bottom number. Okay. Yeah. Pen got stuck. Yes. And then we have the arithmetic operations and, conversions, which are functions. So functions are arithmetic operations and conversions. And then we have common fractions, which are also known as simple fractions. So common, it's like simple, also known as vulgar. Okay, so vulgar is the same as, which is Latin. It comes from the Latin word. You know, vulgar is the Latin word for common. Okay, so we're gonna go on to the other types of fractions. Okay, which are the proper fractions. Where the numerator the top number is larger than the denominator, the bottom number. Which is the bottom number. So for example, 4 ninths. It should also be written like this, whichever you prefer. Okay, so we have another type of fractions. Okay, which are improper fractions. Okay, which is, in which the numerator top number is smaller. That, numerator is larger than it. Okay, I start over again. Here are the fractions. First one, go again about proper fractions. Now let's just do n for numerator. The numerator is smaller or less than the denominator. Okay, so the numerator, think of this way, 4 is less than 9. So the 4 on top, 9 on the bottom. Or I could do it like this. Or. Okay. And with the fractions. There's improper. Okay, so where the numerator is greater than a denominator. So the 9 is greater than 4. I'm gonna put 9/4, or like this. And then next we have mixed fractions. Mixed fractions. Okay. That is a combination of whole numbers, of a whole number. For example, 1 equals a whole number. Start abbreviating, speed things up. And a fraction, which is like 3/4. Okay, and so we got that. So a mixed fraction is like 1 and 3/4. Okay, so the last thing we're going to do tonight is the decimal fraction, which uses a decimal point. And it's, for example, of decimal fractions, it's like 20.23, which is 23/100ths, or 1.75, which could be 1 3/4, or it can be like with money, which is $47 and 25 cents. So decimals equal fractions. Think it that way. Okay, so for example, 0.75 is like having 75 over 100, and which can be reduced. And that's all for now. So next time I'll continue with how to reduce fractions. And thank you for staying with me. And I do have Patreon, so you can support me there with $1 or more. At the time, no one is sponsoring me, but I'll still continue to make the videos. So I will stop the share. And thank you, everyone, and I'll see you next time.